All right, thanks everyone for coming to IO 103, Monitoring and Forecasting Your GCP Costs. I'm Stephen Elliott. I'm a product manager on Google Cloud Billing, and my colleague here, Phil Coletti, that's Phil with two L's, and he's also a product manager on Google Cloud Billing. And we're really excited here to talk to you about cost management in the cloud and on Google Cloud Platform in particular. But just to get started, I just want to get a quick show of hands and get a sense of who's in the audience. How many of you use any cloud provider today? Okay, so vast majority. How many of you are on Google Cloud Platform today? And then maybe the flip side, how many of you are evaluating but not on Google Cloud yet? Great. And then, rough sense, how many of you feel like you are really good at managing and monitoring Google Cloud provider costs? A third. And how many of you feel like you need to learn something or need some help or tools to help with it? Okay, great. Got it. So before we dive into kind of the meat of how cost reporting works on Google Cloud, I want to do a little introductory trip into cost management in the cloud with a company you've probably heard of before, Waze. If you live in the Bay Area, you might even use Waze to get here. Waze was founded in 2008. It was called FreeMap Israel, I believe. And it was acquired by Google in 2013, so now it's a Google company. And obviously, they run part of their infrastructure on Google Cloud Platform, or else I wouldn't be including them in this talk. One of the things they do, which you are familiar with, is their traffic application. They help you navigate and get to where you need to go. They find the best route for you based on help from other drivers. And this is actually a map of where Phil and I work in Seattle, and it's showing you 3 routes from downtown Seattle to Fremont. Now, 2 of the routes I don't recommend, but the fastest route does seem like the route I would take to get from the Hilton downtown to Fremont. And right where that Google Cloud logo is Google in Fremont. And you can kind of see what Waze is doing here. It has traffic notifications based on drivers. So this is all coming in from drivers' apps. There's heavy traffic on the 520 bridge. There's basically heavy traffic everywhere in Seattle this morning at 9 a.m. That's pretty standard. There's also other events like these pink barricades that are showing where drivers are reporting, roads are shut down. There's a policeman apparently in Interbay, and there's construction workers downtown. So the important thing about this is Waze is doing this, as you know, all over the world for millions of users. They're in 185 countries, and they have 500,000 Maps contributors. And we all know that route navigation and route finding is already a computationally hard problem, and Waze is doing a lot more than just that. So it's doing this for millions of users around the world in real time. It's also doing anomaly detection. It's reporting what it thinks might be safety incidents to local authorities. It's doing sentiment analysis on users to make sure that their experience on the Waze app is good. It's taking all of those map contributions in, and it's doing this in every major city. And you can kind of see what I love about this video, and you can see a series of these on YouTube, is how Waze is living and breathing as it's serving its customers. And in particular, all of its services on this chart and on this slide and elsewhere are spinning up and spinning down with Waze customer demand. So in the morning when Waze customers are driving, Waze is spinning up more compute resources. There's more BigQuery activity. There's more big data activity, storage and database management, networking activity. And actually in a chart later on this presentation, you'll see what's happening. And this is a really cool aspect of all of these services and of being in the cloud is that they're all available on demand, and they literally kind of breathe in and out with the demand on the infrastructure. So that's something I just want to talk about and frame this talk a little bit before we dive into the cost reporting tools, is one of the things you probably hear a lot about moving onto the cloud from a legacy provider or operating on various cloud providers is the ability to trade capital expenditures for operational expenditures. So here's just an illustrative oversimplification. Cost on the y-axis and time on the x-axis. And this might be a hypothetical application, and you're forecasting the demand that application will have on your infrastructure. And in the traditional world, you'd have to make sure you plan ahead and buy that infrastructure and procure the hardware in advance. And this timeline could be anywhere between days to weeks, and usually it's more like months, 3 months to 6 months to get the data center in place, to get the capacity you need to run the new application, to get the capacity you need to launch in a new region, to launch your business internationally, to serve international customers. Now, in the worst case scenario, you get it wrong. And your demand exceeds what you planned for, and this either results in unserved demand or unhappy customers. And so that's usually why you try to over-provision to make sure you don't hit that. And then it's a balancing act because you don't want to over-provision too much, because in the best case scenario, you have unused capacity. So the obvious immediate benefit of moving from capital expenditures to operational expenditures is this unused capacity becomes unused capacity savings. So that's capacity you didn't have to use, you didn't have to spin up, and all of those services on the Google Cloud Platform slide that Waze uses don't incur costs for Waze. But there's another value that I want you to think hard about, and sometimes this gets lost in some discussions about cost monitoring and cost forecasting, is the ability to meet surprise demand. So this could be very simply, a social media app in the early 2000s scales really fast and shuts down because it wasn't able to meet demand in its data centers. Or you're delivering traffic more slowly and it's just a bad customer experience. But another way to think about it is also, what are the projects that your company's not doing because your employees are kind of stymied? They realize it's going to take 3 months to get a project off the ground, to even run a pilot, and so they don't bother asking. We all work in knowledge economies. We have very important employees who might be the most valuable thing that we have in our companies. And whenever we slow down the work that they want to do, that has really drastic implications for our business. So one of my colleagues, Matt Leonard, gave a talk with Lucas Carlson at the Broad Institute. And the Broad was the first to sequence the human genome, and if I recall correctly, has sequenced 100,000 since they started. And you can imagine if there's any delay, if there's a significant delay when researchers can actually get results, that impacts not just the Broad, but actually, I mean, this is kind of overemphasizing, but mankind. They're like, the time to science is very long. So some key questions I just want to put in your head, and you can ask yourself these questions as you go through the demo with Phil, are these three. So how much does my app cost? What are my cost trends? And what are the drivers of those trends? And what I like about these questions is they're kind of fractal. They apply to any level of the organization, and you'll find that your CIO or CTO is asking the question, and you also find that the developer actually creating the application, operating the application, needs to be able to answer these questions as well in very fine detail. So we can give you, at a glance, answers to all three of these questions, even for one of our biggest customers. So I want to illustrate this with Waze Carpool. Waze Carpool launched, I think, in California last year and then in Washington earlier this year. And it allows drivers to pair up with riders and for a nominal compensation to be exchanged between the two so that you can carpool effectively to work, spend time with people you enjoy, so you can set preferences on who you drive with, and get there faster in the HOV lane, and reduce commute costs. So this is what Waze costs look like in our reports dashboard earlier this year. So this is kind of a nice view because it also shows you a general pattern with what cloud costs usually look like, which is compute costs tend to be the large cost, and that makes sense. And there's cyclicality and periodicity in your costs. It may correspond to daily cyclicality, so Waze has that with morning and evening commutes. Or like seasonal cyclicality, retail periods, other things like that. But in general, there's a longer-term secular trend of those costs that also keeps the cloud administrator confident that their environment isn't running out of control, that they don't have runaway costs. But just at a glance, you can see something happened earlier last year where there was a big spike. I presume Waze investigated that because that doesn't look like it was normal. Maybe a few months ago, there was a smaller spike, may or may not have been normal, and that's worth investigating. So just at a glance, Waze can log into the Cloud Console on GCP and see what's going on with their service. And again, a service that serves over 100 million users, where they've driven 22.5 billion kilometers, is all kind of represented by the infrastructure on this chart. So then they launched Waze Carpool, and this was the trend after they launched Waze Carpool. And so immediately we've answered at a high level the three questions. What's my spending level? So you have the spending level at any moment of time. What's the trend? And you have this short-term trend, but also the long-term trend, which is more interesting. One of the questions I would want to ask myself launching a new service is the cost growth good? Is it growing sublinearly with customer demand? Is it in control? Or is something happening where our costs are spiraling out of control compared to the demand we expected? And this shows kind of a nice story of what the secular growth was before they launched this major new feature and what it looked like after they launched the feature. And you can also see that nothing big changed about their makeup, at least at a glance here. Compute costs still seem to be the same fraction, BigQuery analysis costs, cloud storage, and so forth. So just this visual understanding of cloud costs is very powerful because the visual explanation is just a really good way to communicate the structure of costs. So I just want to do one footnote before we head into how to track cloud costs, because there's really two ways to go about it. One way is tops down. You could use the resource hierarchy and put resources in a project. Everything on Google Cloud Platform is assigned to a project. And you can set up an organization, folders under that organization, projects under each folder, and then resources within a project. And users operate within projects. They have permissions to create resources within projects. And so if you've created a nice project hierarchy and you've thought well about it, you could have a project that corresponds to an application, and then all the costs in that project are application costs. Or you could have a project that captures all of an environment, like the dev environment. So all the costs in that project would be the dev environment costs, and so forth. The other way to track costs is bottoms up through labels. And labels apply to resources. So you can ask your developers or set up tools that automatically attach labels to resources that are created. And then you can get basically kind of matrix allocation of costs. You might say, okay, within project A, I know my costs are X in total, but I also know that the environment prod in project A costs some fraction of X, environment dev costs some other fraction, and so on. And that's how you can use labels. You can also attach other important metadata, like who's the owner of the resource, what's the cost center, things like that. So these are two things to think about as you're thinking about how you want to monitor and manage costs in Google Cloud Platform. So we're going to focus a lot of today on billing reports, but I just want to make you aware of a couple of other major features that might be useful to you in monitoring and managing cloud costs. One is billing export. The other is budgets and alerts. And the last one, which we'll do kind of an in-depth demo on, is billing reports. So billing export is really where you would kind of just dive in, write detailed queries, and kind of answer customized questions about your cloud costs. All of the labels go into billing export. You see what service was used, what SKU was used, details about the project and the SKU. And over time, we'll be adding more and more information to BigQuery export. And what's cool about this is you can connect to other tools like Data Studio. There's another talk we gave explaining how to do that. And so this really allows you to answer fine-grained questions about cloud costs. The next feature we have, budgets and alerts, is really worth taking a look at. You can set budgets at the billing account or project level, and then set thresholds for when you want to be notified about that budget. And the notification can happen via email or programmatically via PubSub. So email is great for cloud administrators who just want to be aware of things and may not be operating a large-scale operation. But PubSub and programmatic notifications are especially cool if you're running a really large application or if you're technically savvy and can set up really simple responses to those notifications, like, if project A exceeds 90%, please start throttling project A. And that unleashes a very cool solutions for your organization. And Matt and Lucas Carlson from the Broad gave a very cool talk about that earlier. It'll be on YouTube. So now I'll turn it over to Phil, and he'll walk you through billing reports.
So now we're going to dive into the billing reports tool in a little bit more detail. And we'll do that through the lens of our hypothetical enterprise Acme company. And they want to answer the same questions as most other IT organizations. What are my costs? What are my cost trends? And what are my cost drivers? But before we actually look at the tool in too much great detail, a quick show of hands. Who here has used Google Cloud billing reports in the Cloud Console? Looks like maybe 30%. OK, so for some of you, you may have already seen this tool and used it. For others of you, it may be familiar, given some other BI tools that you've used. And for many of us, this may be first time seeing it, so we'll learn something. Could we cut back over to the demo, please? Fantastic. First, let's just take a quick look at the tool. I'll give a quick walkthrough, and then we can look at answering those questions. So for starters, we can get to this by going to the Billing tab and the Reports section. Right at the top here of the page, we have a summary bar, which includes high-level information about what our costs are for our app. Below that, we have a chart that lets us analyze trends and see how our usage breaks down. And then at the bottom, we have a table that summarizes and rolls up the information from that chart. Lastly, on the right section of the page, we have grouping and filter controls that let us slice and dice our data and filter down to the scope of spend that's relevant for us to look at. Okay, so to answer those questions, first, what are our costs? The summary bar gives us a really nice, concise answer to that. So far, in the first 26 days of July, for our demo here, we've spent $1,400. For the entire month of July, looking at the right half of the summary bar, we can see that we're forecasted to spend about $1,800. So we can see easily that the summary bar, it gives us a really nice, quick answer that we can answer that question in maybe 5 seconds. Next, what are our cost trends? In the first 26 days of July, it looks like our costs are down about 3.5% over the preceding 26-day period. But for the entire month of July, it looks like we're forecasted to spend about 8.5% more than we did in the month of June. This is because we're growing, also because July has one more day than June, so we would expect costs to go up a little bit anyways. But to look at these trends in more detail, I'm going to look down at the chart. A few things here to note. One, we have a stacked line chart, so the total height of the stacked line is what we're spending on a daily level. But each one of these segments represents a meaningful portion of our spend. Here we're grouping by project, so each one of these colored segments represents the spend for a single project. At Acme Company, we organize our applications into projects, so each one of these colored segments is how much we're spending on one application for one day. Lastly, we have a dotted gray line here that represents our cost trend. And this is how we get to this forecasted cost number for the month. The forecasted cost is the sum of our actual spend to date and our forecasted spend for the remainder of the month. But to look at it, I want to explain a little bit how we get to this cost trend number. It's a feature we've rolled out recently, and it's pretty powerful. So I'm going to select the custom date range here, just so that we can get a little more context. I'll look at the period from May 1st to August 25th. Okay, so for the purposes of the demo, we created this account sometime in mid-May, and the account grew along with our hypothetical demand, and the cost trend picks up on that long-term secular stable trend, and it projects it out up to about a month into the future. So the way this works is we take the entire history for the billing account, all the spend that you've had to date, and we look for the most recent stable long-term trend. So maybe if you launched a new application like Waze Carpool, it would start at that point. Or if you went through a major cost optimization effort, it might start after that. It also does a good job of ignoring spikes like we see here in the middle of June. So it really just picks up on whatever your organic growth trend is, and will forecast that forward into the future. Great. So now we kind of have a quick answer of our first two questions. What are my costs and what are my cost trends? But we've answered this only for the entire billing account. What if we want to know a little bit more about a single application? In this case, let's say Phil's amazing application, not to toot my own horn too much. We can answer the same questions just by filtering down to that one project. We can see that so far we've spent $450 on the application this month. We're expected to spend about $600 in the month of July, and that represents about a 36% growth over the month of June. Okay. So lastly, the one question we haven't really dove into too much yet is what are my cost drivers? So to do that, I want to go back to those spikes that we saw in June. I've selected the previous month here so we can look at those in a bit more detail. So here we see a spike around June 8th, and we see another spike around June 11th. And I want to know at a high level what changed to cause those spikes. The chart's a really powerful tool for doing this, and we can quickly see just by hovering over this section that this orange slice, which was our good enough project, that really changed a lot. It grew at that time, and it also grew for the June 11th spike. On that June 11th spike, we also see that we had some growth in this blue segment, which was Phil's amazing application. But I can get a little more detail. I want to understand what changed in those applications to cause those spikes. And let's look at good enough project first. So I'll filter down to just that project. And then I want to ask the question, which products or services changed to cause the cost to increase? So I'll group by product instead of by project. And now I can see that BigQuery all of a sudden went from nothing to $28 overnight. And that may have been unexpected. It may have been something we planned for. We can get even a little more detail and see what happened in BigQuery by filtering down to just that product and grouping by SKU to see if there are any trends in the SKUs that we were using. So not surprisingly, it's analysis, not storage, that fluctuated really highly up and then came back down. And at this point, this is about as much detail as we can get from this report, but we might want to go talk to, say, our data science team and learn what kinds of queries they were running. And if they were pulling a data set to build a new predictive model that we get a lot of value out of, that may be totally fine. If, however, we want to trade off some of the flexibility for a little more predictable and controllable costs, we might want to look into something like flat rate BigQuery pricing. Okay. So now I want to go through a similar process and try to understand what happened in Phil's amazing application in the middle of June. So again, I'm going to filter down to just Phil's amazing application. And we can see, just by hovering over the chart, we were spending about $8 a day, and then it jumped up to about $35 a day sometime in mid-June. And that's something I'd want to know, say, what products, what services changed. So again, I'll filter down to just compute engine. Sorry. Jumped ahead. I would group by product, and I would see what products changed. In this case, we can see in Phil's amazing application, we run two products or services, both App Engine and Compute Engine, and Compute Engine is where the change occurred. And again, we can get a little more detail by looking at what our changes were in our SKUs. So here I'll just filter down to Compute Engine and group by SKU. And there's a couple changes that we can see here during that spike. Normally, just by hovering over, I can see we run N1 standard ones, which is our smallest standard machine type of the N1 family. But then right here in the middle of the month, we see a couple other flavors of SKU, N1 standard 8s and N1 standard 16s, which are bigger and more expensive than what we normally run. And again, this is about as much detail as you can get from a high-level report, but you might want to dive into more detailed data in like your stack driver logs or in our BigQuery billing export, or we might go talk to the project owner or the engineer and say, hey, is there a reason why we're running these bigger machines and why we didn't spin them down for a few days afterwards? Additionally, when we see something like that, if it's unexpected, we may want to set up a passive monitoring solution like budgets and alerts so that we're notified if our spend trends quicker than we expect. At this point, we can cut back over to the slides. So now we've gone through a demo of billing reports. We've seen how we can use this tool to really quickly get a high-level answer to our 3 key cost management questions. And we've also seen how we can get to a certain level of depth, at which point we need to go to either a more detailed data source like our billing export or like stack driver logs to get even more rich detail about, say, machine utilization, or we can go talk to the relevant teams to figure out what happened when we see spikes like we did in the middle of June. Cool. So that concludes our demo. Before we wrap up, I just want to highlight a couple of other sessions related to cost management and billing. On Tuesday, we had a talk by James Byers on how to organize and structure your resources, which also relates to the slide that Stephen went through earlier about labels versus projects and folders. Yes, we also had a pretty cool talk yesterday with Dale and Dale from Vendasta, where they did some interesting live demos about how to use BigQuery Export and Data Studio to slice and dice your data. And lastly, Matt and Lucas Carlson talked a bit about how we can control our cloud costs with financial governance tools. We also have a showcase downstairs on the bottom floor of Moscone West. Please stop by and say hi. We'll be there probably after this presentation.